Today we're going to start studying the sum and difference formulas. I would add these formulas to your card so that you have them and you can use them in addition to all of the other identities we've been studying. You use the sum and difference formulas just like we have been using the identities. You use them as substitution. We use these when we have to find the sine, cosine, or tangent of angles that we do not have on the unit circle. So for example, on number 1, we could use a difference formula for sine on this one. We don't want to subtract what's inside the parentheses because if we did that, we would get the sine of 105 degrees. And 105 degrees is not on a unit circle. So when an angle is not on your unit circle, you want to use these difference formulas. We are going to let 135 be our alpha. We're going to let 30 degrees be our beta. We know that the sine of alpha minus beta, looking at the formulas at the top, equals the sine of alpha times the cosine of beta minus the cosine of alpha times the sine of beta. So you're just going to plug 135 in for alpha and 30 in for beta. So it would look like this. The sine of 135 degrees times the cosine of 30 degrees minus the cosine of 135 degrees times the sine of 30 degrees. Since 135 degrees and 30 degrees is on our unit circle, we can now use substitution and plug in values for these 4 items. The sine of 135 degrees is radical 2 over 2. The cosine of 30 degrees is radical 3 over 2. The cosine of 135 is negative radical 2 over 2. And the sine of 30 is 1/2. So now you're going to multiply. And when we multiply things, we multiply our numerators. And we get radical 6. And we multiply our denominators. And we get 4. The negative and the negative equal a positive. Radical 2 times 1 is radical 2 over 4. Since these both have a common denominator, we could write our answer as one big fraction, radical 6 plus radical 2 all over 4. And you're going to leave your answer like that. On example B, we do not want to use a difference formula because we can go straight to our unit circle. The sine of 135 is radical 2 over 2. The cosine of 30 degrees is radical 3 over 2. When you're subtracting fractions, you just worry about the numerators when you have a common denominator. So our final answer is radical 2 minus radical 3 all over 2. In your homework tonight, many times you will just be given the sine of 255 degrees. So you have to take out your calculator and figure out which 2 numbers on the unit circle add or subtract to give you 255. I chose 345. So that means I'm going to let 300 represent my alpha, I'm going to let 45 degrees be my beta, and I'm going to use the difference formula for sine again. So I'm going to plug in these numbers, and it's going to be the sine of alpha times the cosine of beta minus the cosine of alpha times the sine of beta. Again, I'm using the difference formula for sine at the top of the paper. Once I plug in these numbers, I can just go to my unit circle and multiply their values together. The sine of 300 degrees is negative radical 3 over 2. The cosine of 45 is radical 2 over 2. The cosine of 300 is 1/2. And the sine of 45 is radical 2 over 2. So again, I'm multiplying the numerators together. And then I'm going to multiply the denominators together. If I do this on both sides, you can see that I have a common denominator again. So when you have a common denominator, you want to write your answer as one big fraction. So I'm going to go straight to doing that for my final answer. And my final answer is just going to be negative radical 6 minus radical 2 all over 4. So you can see right here you have a common denominator of 4. So you don't need to write them out as two separate steps. You can just go straight to writing your final answer. When your problem is presented to you in terms of radians, you can either figure out what 2 radians add or subtract to give you negative pi over 12 using the unit circle and common denominators, or you could change the radian measure to a degree by multiplying by 180 over pi. So if you do this, you can see that negative pi over 12 is equivalent to negative 15 degrees. So that's why I used 30 degrees minus 45 degrees on my unit circle. So my alpha is 30 degrees and my beta is 45 degrees. Since the problem is presented as a radian measure, when I plug it into the formula, which the formula I'm using here is the difference formula for cosine, I'm going to plug it in as the cosine of alpha times the cosine of beta plus the sine of alpha times the sine of beta. Go to the unit circle, plug in all the values, and multiply everything together. So the cosine of pi over 6 is radical 3 over 2, the cosine of pi over 4 is radical 2 over 2, the sine of pi over 6 is 1/2, and the sine of pi over 4 is radical 2 over 2. Multiply your denominators together and you get a 4. Multiply your numerators together and you get radical 6 plus radical 2. And that's your final answer. So you can see a lot of your answers are going to look the same. You just have to apply everything to the unit circle. On this next problem, we have to find the tangent of 15 degrees. 15 degrees is not on the unit circle, and on this problem, I did not tell you what you have to use. So you have to find 2 angles on the circle that either add or subtract to give you 15. So I'm going to use 45 minus 30. I try and stick with quadrant 1 angles as much as I can. So now I'm going to use the difference formula for tangent, and I am going to take the tangent of 45, because 45 is my alpha, minus the tangent of 30, because that's my beta, divided by 1 plus the tangent of 45 times the tangent of 30. So I'm using these formulas from the top of this notes page. I'm going to go to my unit circle. The tangent of 45 degrees is 1. The tangent of 30 degrees is 1 over radical 3, because tangent's y over x. And then on bottom, it's going to be 1 plus the tangent of 45 is 1 times the tangent of 30 degrees, which is radical 3. So now I have a complex number, so I'm going to have to get rid of the denominator in my denominator, and to do that, I'm going to multiply top and bottom by the denominator in the denominator, which is radical 3. I need to distribute this, so I get radical 3 times 1, which is radical 3, minus these radical 3's cancel, so I'm left with just minus 1, over radical 3 times 1, which is radical 3, plus radical 3 times all this will cancel the radical 3's, and I'm left with just 1. I'm fine with you leaving your answer like that. It will not be left like that in the back of the book. They will rationalize the denominator. To do that, you have to multiply by the conjugate. In this next example, we're going to write the expression as the sine, cosine, or tangent of an angle. So we're going to work backwards. Here I can see that my setup is tangent. Whoops, I did not mean to cover that up. Here I can see my setup is tangent minus tangent on top, and 1 plus tangent times tangent on bottom. So if I'm looking at my formulas, I can see that that is associated with the difference formula for tangent. So my alpha is going to be 140, my beta is going to be the tangent of 60. This problem is presented like the right side of your formula, so I'm going to condense it to look like my left side. So it's going to be the tangent of alpha minus beta, and then I just go ahead and subtract this because it's in parentheses, and this reduces to the tangent of 80 degrees. So why don't you guys try the second one? When you look at the way this is set up, it's cosine times cosine plus sine times sine. So if you look at your formulas, cosine times cosine plus sine times sine is the subtraction formula for cosine. Your alpha is going to be 3x, your beta is going to be 2y, and it's going to simplify to the cosine of alpha minus beta, because it's the difference formula for cosine. Since 3x and 2y are not like terms, you're done. We're going to continue doing the same thing we did with the last two examples on this next one, but the directions also say at the end we have to find the exact value. So when I look at this, it's cosine times cosine minus sine times sine. So that is the sum formula for cosine. Alpha is pi over 16, beta is 3 pi over 16. So this simplifies to the cosine of alpha plus beta. 1 pi over 16 plus 3 pi over 16 ends up being 4 pi over 16, which reduces to pi over 4. So now that we have a spot on the unit circle that we can go to, we can simplify that, and the cosine of pi over 4 is radical 2 over 2. So that's my final answer. The way the second one is set up, logistically, tangent plus tangent in the numerator is the sum formula for tangent. So my alpha is pi over 5 and my beta is 4 pi over 5. So this simplifies to the tangent of alpha plus beta. If I add what's inside the parentheses, that becomes the tangent of 1/5 plus 4/5 is 5/5. That reduces to just 1 pi. And the tangent of pi is 0. Remember, tangent's y over x. These next two examples we're going to verify. Remember, when we verify, we have to verify that one side equals the other. This is the sum formula for sine. X is my alpha, 3/2 pi is my beta. So I'm changing the left side. I'm going to make it the sine of alpha, which is x, times the cosine of beta, which is 3 pi over 2, plus the cosine of alpha, which is x, times the sine of beta, which is 3 pi over 2. I'm trying to show that this side equals negative cosine of x. I can't do anything with the sine of x, but the cosine of 3/2 pi is on my unit circle, and that's 0. The cosine of x I can't change, but the sine of 3/2 pi, the y value at 3/2 pi is negative 1. 0 times anything is 0, and now I have my final answer. The negative cosine of x equals the negative cosine of x. So these verified problems also incorporate the unit circle. If I look at the way B is set up, it's a difference formula for tangent, so alpha is going to be pi and beta is going to be x. So when I use my formula, which you will always get these formulas, you do not have to memorize them, I have the tangent of pi minus the tangent of x all over 1 plus the tangent of pi times the tangent of x. So now you can go to your unit circle and find the tangent of pi. The tangent of pi is going to be 0 over negative 1, which is 0, minus the tangent of x, and then 1 plus 0 times the tangent of x. Well, again, 0 times anything is just 0, so that cancels out, and you're left with negative tangent of x over 1, which is just negative tangent of x, and that's what you want for your final answer. So don't forget to celebrate. On this problem, we're going to find the exact value of the expression under the given conditions. So if you look at what's given to you, there's no y value that's 5 over 13 on the unit circle. So what we're going to have to do is we're going to have to draw a triangle. This information right here tells us what quadrant to draw our triangle in. U, which is the angle, is greater than pi over 2 and less than pi. So that's quadrant 2. So I'm going to draw this triangle in quadrant 2. Remember, when you draw an angle in quadrant 2, you go out into the quadrant you need to be in and make it perpendicular with the x-axis. You want to put U by the origin because that's your angle. Sine is opposite over hypotenuse. When you do the Pythagorean theorem, you get this side to be 12. It is negative because you're in quadrant 2 and you're going to the left. We have to draw a second triangle on this problem because we're also given an angle that's V. So cosine of V, again, you're going to need to draw a triangle that where the angle V is greater than pi over 2 and less than pi. So that's in quadrant 2 again. So I'm going to do that. I'm going to draw that triangle over here. So this is my V triangle. Keep that in mind. When I draw this triangle, I want to go out into the quadrant that I need to be in and go perpendicular to the x-axis, but this is a V, and cosine is adjacent over hypotenuse. When you do Pythagorean theorem, your opposite side will be 4. So I didn't show the work for finding the Pythagorean theorem. Now we want to find the cosine of U minus V. So I'm going to use my difference formula for cosine, which says I need to take the cosine of U, because that's alpha, times the cosine of V, because that's beta, plus the sine of U times the sine of V. So you're going to have to go back and forth between your two triangles. On your U triangle, which is right here, cosine is adjacent over hypotenuse. And your V triangle, which is down here, cosine is adjacent over hypotenuse. Now you got to go back up to your U triangle. This is my U triangle. And sine is opposite over hypotenuse. And back here to your V triangle, and sine is opposite over hypotenuse, which is 5. If you've done this right, your denominators should be the same. So that's something that you always want to check. Now let's multiply these together. Negative 12 times negative 3 is positive 36, plus 5 times 4 is 20. I can write this as one big fraction because I have a common denominator. 13 times 5 is 65. Now I can add my numerators. 36 plus 20 is 56 over 65, and that's what the cosine of U minus V equals. And that's my final answer. This last example, I have to find the sine of U plus V, cosine of U plus V, and tangent of U plus V. So before I do all of that, I'm going to have to draw a triangle. My U triangle is going to be drawn in quadrant 2 again. So let's go ahead and draw that triangle. Remember to label this triangle the U triangle. Sine is opposite over hypotenuse. When you do the Pythagorean theorem, this will be negative radical 11. Don't forget to include the negative with your triangle. I don't know why this is up here. I can't get it off of there. Now we're going to draw the V triangle. With the V triangle, I have to draw the triangle that's greater than pi and less than 3/2 pi, so that's going to be in quadrant 3. So with this triangle, I'm going to go out into quadrant 3, go back up so I'm perpendicular with the x-axis, and I want to label that V. Tangent is opposite over adjacent. Both of those are negative because you're moving left and down into quadrant 3. When you do the Pythagorean theorem, you get the square root of 58. So now what we're going to have to do, plan accordingly for the rest of the room that you have on this paper, is we have to find the sine of U plus V. So we're going to look at our formula, and that's going to be the sine of U times the cosine of V plus the cosine of u times the sine of v. So we need to use our v and u triangles and SOHCAHTOA to find these values. The sine of u is opposite over hypotenuse. The cosine of v is adjacent over hypotenuse. The cosine of u is adjacent over hypotenuse, and the sine of v is opposite over hypotenuse. So again, if you've done this right, these denominators should be the same. So you can write your next step as having, one common denominator. So your common denominator is going to be 6 times the square root of 58. Multiply your numerators and you get negative 35. These two negatives will turn this into a plus 3 radical 11, and you're done. You can't simplify that anymore. You're going to have to use the same two triangles to now find the cosine of u plus v. Using that formula, it's the cosine of u times the cosine of v minus the sine of u times the sine of v. The cosine of u is adjacent over hypotenuse. The cosine of v is adjacent over hypotenuse. Make sure you carry your negatives out with all of this. The sine of u is opposite over hypotenuse, and the sine of v is opposite over hypotenuse. We have common denominators, which are 6 times radical 58. So let's multiply the numerators. Here I have two negatives, which will equal a positive 7 radical 11. And again, I have a negative here and a negative here. That will be a positive 15. And we just leave our answer like that. Last but not least, we are finding the tangent of u plus v. To find the tangent of u plus v, you're going to take the tangent of u plus the tangent of v, and you're going to divide it by 1 minus the tangent of u times the tangent of v. So let's go to our unit circle, let's go to our triangles, and tangents opposite over adjacent. So the tangent of u is 5 over negative radical 11 plus 3 over 7 is the tangent of v. And on bottom we have 1 minus the tangent of u is 5 over negative radical 11 times the tangent of v, which is 3/7. So again, we have a complex number. You have a denominator in the denominator, so you want to multiply the top and bottom by this denominator. So I'm going to multiply by negative 7 radical 11 on top and negative 7 radical 11 on bottom. And I want to distribute this. So when I distribute here, the radical 11s will cancel and the negatives will cancel. So I'll just really have the 7 times 5, which is 35. When I distribute here, just the 7s will cancel, so I'll have minus 3 radical 11 left. On bottom, when I distribute, I get negative 7 radical 11. And then when I distribute here, watch your signs, because the negative here cancels with the negative here. The 7 cancels and the radical 11 cancels, but this negative stays. So it's going to be minus 3 times 5, which is 15. You can leave your answers like that. The back of the book, when you check them, will rationalize. Please come see me if you have any questions on this lesson.